Hello everybody. Today we will discuss about motion in this lecture. In everyday life, we observe that some objects are stationary while some objects are in motion. There are certain objects which are always perceived at rest, like trees, mountains, and houses. There are objects which we sometimes see in motion, like automobiles, horses, and cyclists, and so on. And in general, an object is perceived to be in motion when its position changes with time. Motion and rest both are relative, and this is just a matter of perception from the point of view of the observer. So something can be static with respect to some observer and can be moving with respect to another observer. Just for an example, we can see that cars and passengers inside the cars moving relative to the person is standing on the road, and for the passengers traveling in car, they are both these passengers, they are at rest relative to each other. They are not moving while the person is standing outside sees them moving. So the motion of these people is just a matter of perception, and it's always relative and needs a reference point to be defined, that if something is moving with respect to what it is moving. And again, there can be different kinds of motion, like straight line motion. When some object moves in a straight line, it can be a horizontal straight line or a vertical or an inclined line, but it is a straight line motion. And other type of motion is curved line motion, where the objects can move in different curves, and the objects can also rotate along an axis or vibrate around a fixed point without changing their position with respect to some observer. So in most of the real life situation, motion is a combination of two or more types of motion. Some object can be moving in a straight line, while after some time it may take a curve, or it may be rotating and moving, or vibrating or moving, or rotating and vibrating. So these are the different cases in the real life scenario. We will analyze in this lecture mostly the motion along a straight line, which is one of the simplest form of the motion, and different sorts of motion can be analyzed in its terms. So this is also called linear or rectilinear motion, and it can be described mathematically with only one spatial dimension with positive or negative signs. Say if something is moving forward in a straight line, single dimension, we say it's forward and give a positive sign. And if it goes backward, we just say it's negative sign. This positive and negative is just a matter of convention. We can tell forward movement as negative and backward movement as positive, just on our convenience. But we have to be consistent. In one case we can't take forward as positive, and again in the next case we can't take as negative in the same problem. So we need to be consistent. Similarly, the one dimensional motion can be upward, taking it positive, downward, taking it as a negative sign. Also it can be inwards in the plane of your computer screen or mobile screen, outwards, take a negative direction to this. So this is how motion along a straight line is described. Now we come to the concept of distance and displacement. Say an object is initially at a position O, it moves to a position A. Again from A, it moves to B, and from B, it comes back to A. Let's see that how at different paths, what are the distances. So say OA is 10 kilometer, it moves in forward direction. Again it moves 5 kilometer in forward direction, comes back 5 kilometer in backward direction. So what would be the total distance covered by this object? So this will be OA plus AB plus BA. That's equal to around 20 kilometer. That's the total distance traveled by the object. But distance from starting point to the end of journey, that is OA, is only 10 kilometer. It has moved only 10 kilometer from the starting point finally. So this distance between the starting point and ending point is called displacement. And distance between initial and final points of an object, this has got a direction. Whenever we tell displacement, we need to tell what is the direction of the displacement. So here we say that this is 10 kilometer in the forward direction. It can go back towards O here and say that it would be 10 kilometer in negative direction. So that's how this displacement is defined. It's always equal to or less than the total distance. Nothing can move, nothing can be displaced more than the total distance covered. Displacement can also be zero. If the object instead of stopping at A comes back to O, the total displacement is zero while distance covered will be again around 30 kilometer. So another question arises that how fast a distance is covered. This is defined as speed. So a moving object can take different times in covering the same distance. It can be faster or slower. So some objects are relatively fast moving while some are slow moving. And the quantification of speed, it was first done by Galileo between somewhere in 17th century or so. So even though we knew about all the moving objects, people analyzed the movement of stars and planets, but the speed part was not known, not quantified before Galileo. So the speed was defined as distance covered per unit time. Like speed is equal to distance by time. Then we come to another term which is called velocity. That speed shows just magnitude of fastness of motion. It doesn't show that in which direction the motion is there. So while the velocity denotes the direction of speed, say whether it is moving with certain speed in which direction, that is called velocity. And in a straight line motion, the velocity has only two directions. That is forward or backward. Positive velocity or negative velocity we can tell. And for motion in a plane where it can move, have north, south, east and or west directions. If something moves with a certain speed in a space, in addition to these four directions, there can be up and down directions also in the velocity. And velocity is defined as displacement by time. Now we come to the concept of uniform and non-uniform motion. A uniform motion is called where the complete path is covered with a constant speed. Say an object moves from O to D. This is the initial position, this is the final position. It goes through points A, B, C and finally reaches D. While there are different distances, 25 kilometer, 25 kilometer, 40 kilometer, 10 kilometer, but the speed throughout the all segments is 50 kilometer per hour. So we tell that it is moving at constant speed of 50 km per hour. Now we come to the non-uniform motion where the complete path is covered with variable or changing speed. It can be a continuously changing speed or speed changing in steps. So say again if we are traveling from position O to final position D through these different points, then we see that at first from O to A, it goes at 60 km per hour and the time taken would be around 25 minutes. When it goes from A to B at a speed of 30 km per hour, time taken would be 50 minutes. And similarly, B to C, it goes in 30 minutes for with 80 km per hour and C to D in 15 minutes at 40 km per hour and total time taken is 120 minutes or 2 hours. So we say the time taken is distance by speed and the average speed is defined as total distance divided by total time. Here we see that the average speed is 50 km per hour. A 100 km distance is covered in 2 hours. However, the speed between different segments is different. So this is a non-uniform motion. Similarly, like average velocity is defined as total displacement by time. And now we come to the graphical representation of uniform and non-uniform motion. A uniform motion On y-axis we have speed or velocity, and at x-axis we have time. So this graph shows a uniform motion with a constant speed or constant velocity of 50 km per hour. So the distance covered will be speed into time. So here we see that the speed or velocity is 50 km. Throughout it is constant, and time taken is 2 hours. It's here. So the distance covered should be 50 km per hour into 2 hours. It will be 100 km. So this is nothing but the area below this velocity time or speed time curve. This area, if you can calculate, that would show the distance covered by an object. So it's not only with this straight horizontal line, in any shape of the velocity curve, the distance can be calculated by calculating this area below the velocity line. So again we see that the distance time curve for the same motion, the distance is increasing with time continuously without changing the slope of the line. So this shows a uniform motion, and the average speed is equal to total distance by total time. So total distance is the end of this 100 km. Total time at the end of the journey is 2 hours. It shows 50 km per hour continuous average speed. So by using this distance time graph, we can get the average speed. Now we come to the representation of a non-uniform motion, where speed changes with time differently at different distances and different times. So 25 km, the object runs with a speed or velocity of 60 km per hour. Another 25 km, it runs with 30 km per hour speed. Another 40 km, it runs with a 80 km speed, and another 10 km, it runs with a 40 km speed. This graph shows a non-uniform motion in velocity. The same non-uniform motion can be represented in the form of distance time curve, and we see that it is not a straight line but different segments of straight lines with changing slope. Like this slope shows 60 km per hour, this slope shows different velocity, this slope shows different velocity, this is a different velocity, showing a non-uniform motion. Now we need to calculate the average speed, that is again total distance divided by total time. So total distance here again is 100 km, while total time is 2 hours, and it comes 50 km per hour. We can just take the last point and calculate the average speed. It comes 50 km per hour. This is how we can calculate average speed through distance time curve. Another form of non-uniform motion is where the speed keeps on continuously changing, increasing, it may be decreasing also. So here if we want to calculate distance, it is again equal to speed into time, and already we have seen that it is the area under speed time curve. Here it will be the area under this triangle, and this comes equal to half into 100 km per hour. It's here into 2 hours. That comes, the distance covered is 100 km in this condition also. The distance time curve of this non-uniform motion is not in the form of straight lines but a curve. To be more precise, it's a parabola. Here the instantaneous speed keeps on changing throughout the motion, and the average speed is again equal to total distance by total time irrespective of the shape of the curve, and it is 50 km per hour. Now we have seen that in the non-uniform motion the velocity keeps on changing. This rate of change of velocity is called as acceleration, and it's equal to change in velocity divided by time taken for this change. So like we have this speed time curve or velocity time curve. Here the acceleration can be calculated as 100 km per hour minus 0 km per hour is the change in velocity, and it has happened in 2 hours. So the acceleration will be called as 50 km per hour squared. or in SI units, it will be 13.89 meter per second square. We have seen the analysis of motion through the graphs, but it may not be always handy and easy to analyze a motion by making different graphs. So we need certain equations to describe this motion. The first equation of motion is given as V is equal to U plus AT. The second equation of motion shows S is equal to UT plus half AT square, where V is speed or velocity at any given time, U is initial speed or velocity, A is acceleration, T is time, and S is the distance covered. If we eliminate T from the above two equations, we get another equation, V square is equal to U square plus 2AS. These equations have 5 unknowns and 2 independent equations. So 3 out of 5 variables are to be known to completely describe a straight line constant acceleration motion. So now we come to the derivation of equations of motion, that how these equations are derived. To derive the very first equation of motion, we take a speed time diagram of a constant acceleration motion, where this is velocity, here it is time. Here the velocity keeps on increasing from point A to B. We have initial speed is U at point A, and final speed is V at point B after time t. So change in speed is V minus U in this much time. So acceleration by definition is change in speed by time taken. It comes A is equal to V minus U by t. And rearranging, we get the first equation of motion, that is V is equal to U plus AT. Now we come to the second equation of motion. How we have got this? Again, we take the same graph for constant acceleration motion. Here we get distance covered is area under line AB. So this area, we can take the area of this thing also, or we can take area of OACD plus area of ABC. That will be distance covered S is equal to U into T is this area, plus this triangle is half T into V minus U is this line. We notice the fact that V is equal to U plus AT from the first equation. We rearrange it to get V minus U is equal to AT and put this value of V minus U here, and we get the second equation of motion, that is S is equal to UT plus half AT squared. To summarize at the end, we need to see that what have we understood. So the very first point we have seen in the starting of this lecture, that motion is a change of position relative to a reference, and it can be described in terms of the distance moved or the displacement of an object. The next very important point which comes out of this lecture is the quantification of speed. That is, the speed of an object is the distance covered per unit time, and velocity is the displacement per unit time. In more simple terms, the velocity is nothing but speed in addition with the direction. And the speed is defined as distance by time, while velocity is defined as displacement by time. The motion of an object could be uniform or non-uniform, depending on whether its velocity is constant or changing with time. This is an example of a constant velocity motion, where the velocity or speed remains constant throughout the time, and here the velocity or speed keeps on increasing, or it can be decreasing also with time. And speed and velocities, they can be graphically analyzed. Next important thing is the quantification of rate of change of the speed or velocity. This rate of change is called the acceleration, and it is the change in velocity per unit time, defined as change in velocity divided by time taken. And finally, in this lecture, we have seen that how to describe the motion of an object using algebraic equations, and these equations are sometimes called SUVAT equations, SUVAT equations. The first equation is
V is equal to U plus AT. The second equation is S is equal to UT plus half AT square. SUVAT are the five unknowns SUVAT which are there in these equations, and there are two equations, so we have to know at least three of the parameters to define any motion. From these two equations, two supplementary equations are also deduced, that is b square is equal to u square plus 2as by eliminating t from these two equations. Using this, we can analyze the motion without having to know the time part in it. In the second equation, we get by eliminating acceleration from these two equations that shows the distance covered when initial and final velocities are known. Using these equations, we can analyze all simple rectilinear motions, uniform acceleration, different motions like movement of vehicles, ships, and objects thrown vertically up or falling vertically down can be analyzed using these equations. With this, we come to an end of this lecture. So, happy analysis of different sorts of rectilinear motions, and hope to see you in next lecture with some new subject. Thank you.